Thank you very much. I think I also struggle with some of those words, especially with the waveguide combiner. Anyways, the words seamlessly functional in this title of this talk, they are derived from Dispelix vision and mission statement. And they describe how we think the AR technology should be. But before I get started, I really would like to see who do we have in the audience here today. Anybody who is working or developing hardware, please raise your hands. Excellent. How about software developers? Great. Anyone who might be looking for an AR device, end device? A few. Excellent. So this talk could have also been called Successful Together, because all of us, the hardware developers, the software developers, the end customers, and organizations like AWE, we all do our part and contribute and work really, really hard in order to make this market very successful. I will talk first a few words about Dispelix as a company intro. Then I will zoom in and talk a little bit more of the waveguide, also look at the AR device, AR glass device, discuss about the broad compatibility, about the interfaces, and then close with a few words of the teams and activities, what we have at Dispelix, and who are actually making these different waveguide combiners possible. Dispelix was, so let me start with a few words of Dispelix. Dispelix is a waveguide combiner designer and component supplier. So what we do not do a full device, but just the one little component within the system. It was founded in 2015, and it is it was a spin-off of a research institute, VTT. Our headquarters is located in Espoo, and we also have a second Finnish location close to an eastern border, Joensuu. We also have offices in US and in China. During the last 8 years, Dispelix has grown into up to 150 people. And one fun fact is that we have 32 different nationalities within this group. We have very strong support for innovation, and our teams have generated more than 150 patents, approved patents, and currently we have more than 200 patent applications that are pending. With all these innovations that we have in waveguide design and also manufacturing process, we contribute our part and we enable the seamless and the functional merger of the AR dimensions into our lives, and hopefully only when we want it. In order to reach this goal, all these subcomponents needs to be tuned to play together, very similar like in an orchestra, how orchestra is playing together, symphony or concerto, and each one of these players bring their part into the whole device. In Dispelix vision statement, I really like this part where technology no longer looks, and I want to add, as feels like technology. In our vision, the AR displays, they should look like ordinary glasses. And believe me, that's not a simple task, as many of, and especially in the hardware part of, you know that. Let's take a look at AR glasses from the hardware point of view. Here are some components that you would potentially see in a very basic AR glass version. If it's a standalone unit, you might want to have battery, also some sort of wireless connection. And you might also have a lot of different sensors, like let's say eye tracking or gesture sensors or some other portable, some other sensors that you know already from your other portable devices. But in the very core of that AR enabling technologies, you have the display engine, and also this is where the image is generated that are combined with these optical combiners. In this talk, when I mention display engine, I actually use the word light engine, and that's what I define where all the electronics, the drivers, and all the optic systems are part of that. Here in this model, it's one of our demos, you can actually see that the waveguide combiner takes quite a bit of large base. It's a larger component, and it has a lot of different criteria that it needs to fulfill. And I will discuss that later in more detail. But there's also other things that relate very closely to the waveguide combiner, such as if you need to add a prescription for a lot of us who needs some vision correction. But I want to go back to where I started for the words seamless and functional, and just stress again how important it is that all these different components and subsystems, that they need to work very flawlessly together. And that's why when you define all these different interfaces, it is extremely important. So next, if I may use my musical vocabulary, I'm going to do my waveguide solo here now. If you've been wondering in the last few minutes, what's a waveguide combiner? This is it. It looks very simple, but there's a lot of sophistication and complexity built into it. These are diffractive surface release gratings, and they are made out of high refractive index inorganic materials. The function of the waveguide combiner is to transfer the input generated by the light engine and bring it through the waveguide into a virtual image in the user's eye. I'm going to now explain a little bit of the different gratings that we have in the waveguide combiner. You see that round spot right there. That's what we call incoupling grating. And that's the interface to the light engine. That's where the input beam from the light engine is received. And so incoupling grating, and we call that IC for short. Please pay attention because I'm going to ask you that question later. From there, the beam expands to a different grating, which is called EPE, exit pupil expander. And as the name says, these gratings expand the beam, and it guides the light based on total internal reflection method. So basically, it bounces between these two glass surfaces. The third grating is an outcoupling grating, OC for short. That's our lingo. And here the light deflects back to the user's eye, when then you'll be able to see then the image virtually. You really cannot see a lot of the gratings, and you know what, that's purpose. This is actual photo. So we try to make them as invisible as possible, and that's one of the reasons. You might be able to see a little bit of the Bachmann type of structure in there. It's also worth to mention that all these colors, you know, the RGB colors that are generated by the light engine, they propagate on one plate. So no separate plates are needed for each color, and this results quite a thin and light waveguide. Now let's talk about broad compatibility. Broad compatibility is very important. So let me give you an example. We have a standard waveguide called Selva, and this one waveguide, it supports a monochromatic and also full color. Also, it supports a wide range of field of use, and you can also use the same waveguide design as a monocular or binocular setup. So it's rather kind of a one-size-fits-all, not quite, but you know, that's our approach for standard products. And you know, if you don't have a lot of budget or time, or you're short with time, you can of course then explore with these kind of waveguides. We also make them custom waveguides that are very targeted to a certain specification. Dispelix waveguide, they can accommodate a variety of different light engines, DLB, LCOS, micro LED, or LBS, laser beam scanning systems. We like to make our eye box, which is the area where the virtual image can be seen. We might like to make that very large. For example, we come in different shapes and sizes. Our interpupillary distances are different. So we want to make sure that these designs also match with, people with the different dimensions in their face, I guess I should say. But they still would be able to preserving the visual comfort. The eye relief is a distance between your waveguide combiner surface and then your eye. And here also you need to make sure that there's enough ample room in case you need to have any prescription integrated with the waveguide. So the interfaces. I see the interfaces more as on kind of like a handshake between different components. And the three building blocks that we have defined is the mechanical design, the in-coupler grading in the waveguide, and then here, let's guess. What is the intercoupler grading in short? I see, perfect. Haha, somebody's paying attention. And then we have this exit pupil beam from the light engine. So these are kind of like that needs to have the handshake, and that interface needs to work really flawlessly. And when that is working well, then you will have a very good XR experience. You have a good colors, the uniformity, and the brightness, and all that good stuff what we want will happen. Then we have a mechanical design. So in the mechanical design, we specify the coupling angles, and then the distance between the waveguide combiner and the light engine. When you have these correct coupling angles, it ensures, like when you are looking at, for example, a stereo image, that then all these are aligned properly. And it also influences where your virtual image is displayed. Is it right at the center, a little bit below, or above? If you also have a good and defined really well of these coupling angles, you help to eliminate any potential artifacts. And it also helps you to generate very feasible assembly tolerances, which is very important when you go into mass production. Naturally, also the clearing distances and the interfaces, both the horizontal and vertical, they should give enough design freedom to enable fashionable glass frames. Then we have the beam characteristics. So I had a lot of discussions with our light engine partners to really jointly define what are the characteristics of the beam, how they should be, maybe also from the grading side, because this is the handshake again, and we need to have the most efficient and uniform image. And it's sometimes a little bit negotiating what can be done, how each of us what can we do in order to get a good beam quality, or actually image. And the beam is very, very important. Typically, if the beam is very collimated and it's when it's received in the IC, so in coupling grading very uniformly, then it also the virtual image tend to be rather uniform, and then you'll be able to focus the virtual image in a very comfortable distance. The luminous spectrum. So our in-coupler grading have been tuned to guide the wide range of RGB color band. Therefore, the broad visible spectrum can be used, and the color gamut can be tailored. And we've tailored our in-coupling grading so that we'd be able to be as compatible with various light sources as possible. But maybe a note here that sometimes for the LED light source is a bit different, so we need to have a separate design for that. So let's look at the combiner requirements now from the full device point of view, like the AR glass, and not in the micro scale anymore. We have defined 3 different comforts, the social, wearable, and visual comfort. And the waveguide combiner plays a big role on all of these, and the right design supports all these different comforts. So let me first start with the social comfort. So social comfort, we can also look at like a sub-elements, which would be the aesthetics, eye contact, and privacy. Do you remember the waveguides that I showed you where it's just a waveguide picture where there was no gradings that you could not see? And as I said, these are very purposely done because also you don't want to see any of the gradings in the AR glasses. And also the smaller footprint the grading is, the better. One should also be able to establish a good eye contact when you be talking with somebody. You don't want to have any disturbance in the gradings when you talk to somebody. My colleague here, Heini, when she was wearing these, our demos, she's actually looking at a virtual image. And I was actually surprised, but she told me, like, yeah, I was looking at some virtual image. And maybe that's why she's smiling. She's looking at something fun. But anyway, here we can prove that we have reached our target that no world-side leakage or glow is present. To reach a wearable comfort, we look at topics like a weight, balance, so easy to wear, and the eye relief. The eyeglass industry has already perfected the wearable comfort. Therefore, we try to follow it as much as possible. And we take a lot of these designs from there. And one thing about how we can influence is, for example, where we position the in-coupling grading. And we typically now position it here on the top corner, kind of by your temple. There it's very easily be integrated with the light engine. Missed a slide. So this was the slide for what I just said. For visual comfort, we look at the eye box size and virtual image brightness and sharpness. So for example, if I'm wearing AR glasses and I'm moving them around, it's important that I still be able to see the virtual image. It would be kind of pity that it has to be very strict, and then if you move a little bit, you won't be able to see it. So that's important in the visual comfort. And the image itself needs to be also bright enough so that you'll be able to use it in a daylight when it's bright. And then also the MTF, or the sharpness, is sharp enough that also like the font size is readable. So, up to now, we have looked at different things which are considered when designing the waveguide combiners. In closing, I want to have a few words and introduce a few of our teams and the different processes that they are doing in actually to make and produce these waveguide combiners. I will start with the very core of our company. It's our software development team. Since the beginning of Dispelix, this team has developed the proprietary optical software to generate first simulations and then also very complex gradings that are needed for the optical combiners. One thing that we are very proud of is that these simulations, they match very well on actual products, and their performance is almost identical oftentimes with the simulations over and over again. So in advance, we have already concrete knowledge when the grading is meeting the targets. Then we have the R&D team. And the R&D they have multiple functions, but they're kind of like the guys who just roll up their sleeves and get things done. So they do functions such as optical design, they do the prototypes, they test and validate together with our quality control team. They look at different materials. They look at the different manufacturing process. So basically, it's kind of like a mini factory. They do everything with full steam, and they have a lot of different activities. Then we have our mass manufacturing development. This team, together with our supply team, they are kind of close to my heart. That's where the big business is made and a lot of volumes go through. Our manufacturing development team, they know every step of what it takes to produce a waveguide. They spec them. And they are really our manufacturing experts. Their know-how is transferred to our partners, our suppliers for manufacturing. So our manufacturing suppliers take actually the function of the high volume production. But we handle the whole process. So we have also a sales, supply chain management team who handle the whole order process all the way to the end of the delivery to an end customer. And to reach that seamless and functional product, we have a very important step, which is the quality control. That we need to measure, okay, have we really designed the product we had, have we produced the product that we had designed for? Our quality control team is interacting with the R&D team all the way to the end inspection of the final component. And together, our metrology equipment vendors, some of them here today, these teams have developed and built some unique systems that never existed before. And this is really some pioneering work. As I said at the beginning, we are not doing this alone. So far, all the achievements that we've achieved is because of also many of you. So I thank you, and I think together we can be successful. Here's a list of some of our partners and collaborators. And again, thank you very much for being part of that ecosystem. I think we all need to work together. And in closing, I want to invite all of you to visit our booth. It's the 212. It's right at the main entrance on the right-hand side. You cannot miss it. And there I have two of my colleagues with me, and we have demos where you can just experience yourself our AR waveguide combiners. So, thank you very much.
Thank you very much. This was Pia, Vice President of Dispelix. And if you have a question, I would ask you to ask her directly right after this, because we don't have any time left, unfortunately. But you will be here, you will be at the booth, so please grab her, please go to the booth and check her out. I think this was an amazing talk. Thank you very much.